Webinar on basic cybersecurity for industrial control systems. This is Oliver Wang with Moxa, and I'll be moderating the webinar. We will have a Q&A session after the presentation to address as many questions as we can. And do let us know if there are any challenges that you are facing that are not covered in today's session. We definitely want to hear about those. Today's presenter is Mike Werning, a senior field applications engineer here at Moxa Americas. Mike has over 20 years of experience in the design-in of industrial networking infrastructure, embedded computer hardware, software, and systems. He provides consultation for customers designing automation and M2M applications and delivers training for industry professionals. He is a Cisco certified networking associate and has been a guest speaker at various industry events. I'll go ahead and hand it off to Mike.
Thanks, Oliver. Thanks for that introduction, and thank you to everyone that's joining us today for this webinar. The title of today's webinar is Basic Cybersecurity for Industrial Control Systems. For those that aren't familiar with Moxa, I wanted to give you a little bit of a background on who we are. We've been in business since 1987, providing serial connectivity products, and since then we've branched out into several areas focusing on really on the convergence in the network. Major product areas are industrial Ethernet solutions, including Wi-Fi cellular, industrial computing, connectivity, IP surveillance, and remote automation. So this is a screenshot of our website at moxa.com where you can always go for more product information. Today's abstract of this presentation is really about industrial engineers becoming aware of the importance of network security for today's systems. We hear in the news that attacks are more and more commonplace on industrial control systems, and there's availability of tools out there that make them very easy targets today. So years ago, networks that were not connected to public networks were considered safe, but today these are all interconnected with the internet, and the challenge is really how to make them secure. So this has caused industrial engineers to take a step back and figure out how to secure these existing systems, as well as to rethink the go-forward deployment strategy for new systems. So we're going to look at some of these topics today, and as well as provide you with some best practices in securing industrial networks. Before we get started, though, we wanted to do a live poll and gauge what your level of experience is with cybersecurity issues.
So everyone, you should be able to see the poll pop up on your screen there. So go ahead and choose all that apply. You're not limited to just one.
So have you personally experienced a breach? Do you have experience designing, deploying security measures? You know enterprise security, but maybe not industrial systems? Or my hacker call sign? My hacker call sign is widely feared and respected. Or everything is new to me. Please be gentle. Some interesting responses there.
All right, we got a lot of votes in. We'll go ahead and close the polls in 5, 4, 3, 2, 1, and let's take a look at those results.
Looks like the majority of you have some experience designing and deploying security measures. Well, that's great. Enterprise security, but not industrial systems. That's excellent. So, but oh, look at this. Everything is new to me. Please be done. So there's a vast majority of people where this is new information. So hopefully this is going to help you with your understanding and really get you steered in the right direction. Okay.
So we'll go ahead and resume the presentation.
Okay, excellent. So some of the challenges that are being faced in the industry is how to provide secure remote access. And this is, how do you ensure that your information is not being changed when in transit on the network? So how do you protect your confidential information? When you're on public networks, this is very important to be able to maintain the integrity of the messages that you're sending between 2 points. And what about securing existing systems? So what do you do about those previously unsecured networks that you have out there? How do you prevent devices from being connected to them that shouldn't be there in the first place? And what do you do to prevent unauthorized use inside a facility? In addition, there's lots of standards out there in the industry. So which ones do you pay attention to? So some common questions faced when having to secure an industrial control network. So if we look at the threat landscape today, we see that there are some threats out there. One of those is from search engines that target industrial control systems. So one of those is called the SHODAN search engine. This is interesting because SHODAN builds itself as the search engine for the Internet of Things. And we start to talk about the industrial Internet of Things, it becomes very concerning that there's tools out there that are designed to find these systems that are out there. But you don't really need, SHODAN to do this. You could just use Google and their advanced search techniques and to create an exploit to find control system devices out there on the network. And we've seen this recently just in the news with recent cyber incidents that were reported. So what can you find out there? There's lots of industrial control systems such as RTUs, PLCs, SCADA system, amongst others out there. Typical applications, you can find industrial transportation systems, power management systems, security monitoring, process control, and the devices that are all involved with that technology. Serial port servers are particularly troubling since they're transporting already insecure protocols. So to someone that knows what they're doing, they can become an attractive target. So what we're seeing over the recent years is that industrial control systems are in the crosshairs now. So there are more and more incidents year over year in this industrial space. And the attacks are getting more specific, indicating that there's a more advanced, more educated people behind these attacks. So a lot of these devices from different vendors all rely on similar technologies as well. There's open source software and that now. So we're really seeing that there's no one vendor out there that's immune to any of these exploits. So there is no magic bullet when it comes to choosing a vendor. So Department of Homeland Security states that cybersecurity is one of our country's most important national security priorities. So important they've established an entire division called ICS CERT, which stands for Industrial Control Systems Cyber Emergency Response Team. And these guys are just dedicated to industrial control systems. So they do things like publish known vulnerabilities on ICS equipment. They communicate with vendors like Moxa and Siemens and others that are in the industry to notify them of problems or in things to address. They raise the awareness of latent issues in the industry and as well as publish safe practices to those in the industry to help them get started with industrial control system security. So if you've ever not been to ICS CERT's website, I highly urge you to go do that and at least take a look at the recommended practices there, and you'll find a real good, easy to read start to get started in ICS security. So if you refer to the graph that I show here on the screen, you'll see that we have this pie chart here. And this is from incidents that ICS CERT had responded to back in 2015. And there was roughly 300 incidents that they responded to. Now this is just incidents that a company has invited them to come in and help them mitigate a problem or to audit their systems to find out what their readiness is. So if we look at this data, we see that critical manufacturing is now the largest piece of the pie here. And compare that to energy sector. Energy now is number 2. In previous years, that was not the case. So energy had been the largest piece of the pie. So we see now the target has now shifted over to critical manufacturing. So there's a number of reasons why this might be occurring, but one of them, it's believe that the energy sector has been taking a proactive look at ICS security over the last 3 or 4 years now and is really starting to shore up that, that sector. So it's also important to note that, not everyone has to respond to ICS CERT or tell them about the security. And as a matter of fact, most incidents never go reported because no one wants to really raise the red flag that their network is under attack. So recognizing that there is a need for ICS security, the U.S. has been pushing over the last several years to improve ICS security. So back in 2013, the President signed an executive order that called for the development of a framework that could be used by ICS companies to improve security in critical infrastructure. So about a year later, 2014, NIST was the organization that then released the first release, and that's this Guide to Industrial Control System Security 800-82, and this is another very good resource for you to go out on the internet and download the security standard and take a look at what's inside. Now, the intent of this framework was not to reinvent the wheel when it comes to network security, but to leverage the best practices in the industry that already exist. So if we look at some of these, what standards there are in the automation field, we see that there are many. If you refer to the graph, you can see the different sectors and how they map in. So you see energy in orange, industrial automation in red, and IT-centric standards in blue. And you see how they relate to operator and details of operation on the left-hand side of the graph, and more the manufacture and management aspects that are more geared toward the manufacturer of a device on the right-hand side. And you see some of these standards, are far to the left or far to the right. But one of them that's rides the middle very nicely is this ISA 99 IEC 62443. And it's one of the reasons why it's been adopted as really the industry standard for industrial automation today. So 443 has been adopted by global integrators for the design of industrial control system because of its applicability to operators as well as the integrators and developers. So if we look closely at 62443, a little close in view, it shows you that it's really required that you have cooperation between the plant operators, the system integrators or system level designers, and the component manufacturers in order for this cybersecurity to really work. So what this means is that you can't just address security at one level, say at the component level, and expect your network to be secured. So an example here, a component manufacturer such as Moxa has requirements on it to provide functionality in our devices that will allow a integrator to provide or to create a secure network. So we also have some requirements that fall upon us to have policies and procedures for responding to, let's say, ICS CERT advisories and creating patches and firmware and things like that. All right, so if you look at a system integrator is someone that's involved with the integration of components to create an entire system. So they also have the requirement to do the configuration and the smart configuration of those components. So they own that piece there. They also own the design component where you have to come up with a secure design. So designing for secure zones and conduits and designing secure systems overall. So, and then finally the plant operator. So their responsibility is the maintenance and the update of the security functionality according to changing environments and circumstances. So being able to periodically look at their devices, find out if there's new security vulnerabilities, and then patching them. So you can see this whole thing doesn't work if one layer is missing or one layer chooses not to participate. It really requires cooperation. So whichever security standard you choose, they all really have this sort of design in mind, which is called defense in depth. So defense in depth is a concept of defending the networks to resist from things like passive monitoring. So this is providing secure remote access to your devices. Also, defending inside your network with the use of firewalls and intrusion detection to resist against internal attacks. And they call this really defending enclave boundaries or zone boundaries. You also have the requirement to defend your computing environment, which is really the the DMZ for your computing environment. Also, the concept of layering these defenses. So each mechanism that you put it in the design of your network should be such that if there's a breach, it doesn't provide an all-access paths to the rest of the network. So layering your defenses in the network becomes very important. So you can see central to all cybersecurity standards is really the need for security lifecycle and processes. It's the implementation of countermeasures and verification that they work, networking, ongoing monitoring, and maintenance of those networks. It also involves the concept of network segmentation. And the segmentation is breaking down the network into physical or logical zones with similar security requirements, and then defining those borders very clearly between those zones and identifying the connections between them. And they refer to these in 62443, for example, as a conduit. You also have to design the zone-to-zone interaction. So look at your protocols that are running on the devices and identify that traffic that's required by those industrial field bus protocols, for example, and which traffic can be allowed over these conduits. You also need to identify the requirements for safe communication between zones. So what I mean by that is, devices at layer 1 here, or level 1 in our controller RT cell, should be able to access devices in level 2 directly, but not to level 3. And likewise, devices in level 3, our process information network, should be able to get to level 2, but not reach all the way down to level 1. And finally, level 4 should never be able to get to level 3 without going through the DMZ. So that sort of gives you, the idea of the interactions between these zones and levels and what they're talking about when they talk about the defense in depth and the zone and conduit model. So remote access is also a common need for distributed control systems. If we were to monitor this site from a remote control center and utilize public infrastructure, we open up the site to possible attack. It exposes our network. There's really no security. So in order to mitigate this type of attack, the typical way you do this is by applying a VPN. And a VPN provides for secure remote access and provides a secure tunnel between our control system and our field site in this example. So VPN, an example would be an IPsec VPN. So there's also risk of compromise from inside of our systems as well, and we need to provide some sort of critical device protection to protect our PLCs as well as create secure zones inside the site. What's to prevent somebody from coming up and connecting internally to our factory and connecting to devices and maybe changing the programming or something of that nature? So we have to provide some sort of critical device protection and some devices that isolate our zones of trust. There also could be the need to protect a malfunctioning device, like a malfunctioning PLC, or maybe an unauthorized connection has caused a device to malfunction and can cause problems such as broadcast storms and things like that. So there's a need to isolate those devices as well. And the way we do that is by implementing a secure router with a firewall and or NAT features. So if we look at an example of our layered solution in a factory network, we see secure remote access at the edge of our network, or public-facing network, and the technologies that you would look for there are VPN, firewall, and DMZ capabilities, potentially. As you move inside of our factory site and segment between our site and our zone, and here we see a functional zone 1, that's typically done with a firewall. As you move down internally to a manufacturing cell or a particular cell within the network, That's where we see technology like firewall, deep packet inspection, and network address translation. And Moxa has products that fit each one of these different areas in our EDR product line. So a real-life example here is a gas transfer station, and we can see that this particular customer has implemented physical site security, which is very important as well. So preventing somebody from just going up to the control cabinet and opening it up and doing whatever they want is very important. And also providing secure network zone. And here they've used a VPN device to provide the remote connectivity and the firewall to limit what traffic goes through there. This leads us to our next live poll. Which security guidelines are important to your industry? Let's see here.
All right, so we got 5 choices here. NERC SIP, IEC 62443, NIST 800-82, ISO 27000, or other, we're not sure. Now, if you're able to, if you have an awareness of other security guidelines that we have not listed here, we would love to hear from you either in the questions pane, if you want to send it to us, or in the post-webinar survey. All right, so looks like people are wrapping up their votes. I'll go ahead and close this poll in 5, 4, 3, 2, 1, and let's take a look at those results. Mike, are you able to see these results?
Yes, yeah, I see them now. So other or not sure, interesting, and 62443, so that's right along with our data. So for industrial automation guys, you're looking at the right spec there. For the energy people, looks like NERC SIP, and not sure. So if you're not sure, this is a good opportunity to get some more information to take that next step so that you can be sure. And you know, as a potential next step for you, if you're not sure, is really to engage a security consultant. And there are several industrial control system security consultants out there in the industry that can help you through the process. And so we would definitely recommend that you would take that step. Okay. Okay, so are we back here? Can you see this slide? It should say secure remote access.
Yes. Yes.
Okay, so we talked about secure remote access before. So let's drill down a little bit about VPNs and how they're used here. So in the past, companies used point-to-point leased lines in order to create private networks. This approach obviously is pretty expensive by today's standard. The availability of the internet really, drove down the need. It really drove the need to create virtual private networks, which can take advantage of low-cost, internet accessibility. And so VPN allows our data to be secured in this environment. So VPNs, they really just do this. They create a secure tunnel between 2 points. So they provide authentication or identity validation, which is establishing which 2 parties are authorized to speak to one another. They provide data integrity through the use of hashing algorithms. This is preventing anyone from changing your data as you communicate between two parties. And then confidentiality through encryption algorithms. And this confidentiality is can have different levels from the DES to AES, the Advanced Encryption Standard, which is the best practice today. So VPNs are used for different communication needs. So in automation networks, we see 2 distinct requirements. The ability for 2 sites to have a constant on-network connection, and this is the LAN-to-LAN type of a connection, which typically uses IPsec VPN and has the most compatibility with third parties. There's also a need to provide on-demand network connectivity to support periodic connectivity for maintenance or remote access users. And this is typically accomplished using L2TP or OpenVPN, which is another option today. So some best practices when it comes to VPN. So VPNs are public-facing. So management to the VPN interface should not be possible. So you want to restrict access to the device, which also means no ping response from the WAN for a lot of customers. So you make it hard to find that the device even exists out there unless you know where to go. Using a strong password policy, this is always a great policy, really, in logging failed attempts to log in so that you know when you're under attack. And selecting strong encryption. So these devices support lots of different encryption methods, some for backward compatibility and legacy connectivity. That's why they're there. So really the recommendation is using the advanced encryption standard if it's at all possible for you. And then once you establish connection through the VPN, you want to limit what you can do through that VPN, and that's where the firewall rules will come in. So some VPN examples, most people think of the typical wired sort of VPN where you've got, fiber or Ethernet connecting to it. But there's also VPN for cellular for remote connectivity. So in the industrial transportation market, we see cellular used quite a bit, and VPNs can be used over that medium as well. So some Moxa devices where you can get VPN. So I mentioned earlier the EDR series, which is our industrial secure routers, the 800 and 900 series. If you're building embedded computers, we've got the UC8100 with 4G LTE that also supports OpenVPN and IPsec VPN, as well as other secure protocols. And cellular routers with our OnCell and 5104, and even the IO logic. So smart remote IO with the 2500 series, if you connect this up to the cellular network, you can use a VPN. In the next section, we're going to discuss firewall features. So we spoke about firewalls before being used to secure our zones and provide that layer of trust, either between wide area networks and local area, or two local area networks with a bridge. So these are used to create restrictions on the network services that can communicate, and really establishes our zone-to-zone defense. So there's a couple of different types of firewall. One of them is called a router firewall, and the other one is bridged, and which type you depend will really depend on your application requirements. So if we looked on the left-hand side, you see you have, on a router firewall, you have two different subnets on each interface, an outside or public-facing and the inside. And contrast that with a bridge firewall, which has a single subnet that spans both. So single subnet, we find this more and more in industrial control systems that are designed based on flat layer 2 networks. So the basic operation of a firewall is either to accept or drop traffic based on policies that you set up. Those policies can be based on the IP level, the IP address, the MAC address at the MAC layer 2 layer, or TCP UDP layer 4 kind of information. So it's very, very simple in operation, but not so simple to set up sometimes. So firewalls need policies and rules to be set up. And one difference between selecting an industrial firewall supplier like Moxa versus an enterprise one is that, we know about the well-known industrial protocols. And so when you go to our pull-down list to configure it, you'll find things like Ethernet IP, Modbus, and Profinet in there. So you'll be able to select from those, and it just makes it easier when when the implementer has to create policies. So once you create a policy, you're not going to stop at just one. You're most often going to have a list of these things. So the way the policy processing goes is that these lists are sequentially checked until a match is found. So any traffic that you want to allow, you put a rule in there and you say accept this kind of traffic. Anything that you don't want is caught by the default rule, which is drop. So they refer to this as a positive listing or as a white listing. So as a best practice, always use a positive or white listing, dropping everything but the specified traffic. Therefore, you've got the best control over the traffic in your network. So firewalls, allow an administrator to permit or deny based on layer 2, 3, and 4. But what about the application layer? So what about application protocols like Modbus? So in order to further restrict which commands can be sent, you have to be able to use deep packet inspection. So deep packet inspection looks at the actual protocol as it goes through our firewall, and you can make decisions based on which commands to allow and which ones not to allow. So here's an example of that. So in zone 1, you see that this might be our outward or public-facing network. You can use a firewall here and drop all Modbus traffic, no problem. Don't need DPI for that. But as you go into zone 2 here, you might have HMIs or something on this part of the network that you want to allow access to devices, but maybe only read access and not write. So in order to do that, you would have to use deep packet inspection to be able to look at the actual commands that are going through the firewall to limit where you could read and where you can write. And this leads us to our next poll. So which industrial protocol is most prevalent in your industry? So as this clears up for me, I see Modbus, Ethernet IP, SIP for the Rockwell folks, Profibus or Profinet for the Siemens guys, and those related, EtherCAT or DNP, DNP3.
We'll let you guys vote on this. If you're working with a protocol that isn't listed here, we would want to, if you're willing to, provide that information to us so we understand what other needs there are out there. So if there is a protocol that's not listed and you care to let us know, use that questions pane or let us know in the post-webinar survey. So we'll give you a few more seconds. Last chance to vote. 5, 4, 3, 2, 1. Let's take a look at those results.
Okay. Oh, looks like Modbus is pretty big up there, but Ethernet IP, so SIP is right. Those are the two big ones, Modbus and Ethernet IP. So Profibus, Profinet, not so much. Now, I'll bet you if you were in Europe, that would be the opposite of the Ethernet IP. But very interesting results, so great. Thanks for sharing that information with us. Okay, Oliver.
All right, we're back.
All right, great. Excellent. So we are back now. In the next section, already we've talked about VPNs to provide secure remote access. We talked about using firewalls to create that zone-to-zone restriction. But what about the other devices that you have in the network? So that's what we're going to discuss next. So here's an application example, and here you see this network's, public-facing networks are secured by using a VPN device, and you've got secure remote access out at the edge of the network. And you see we've got some firewall devices deployed in here on each one of our zones, creating a secure network zone there. But what about those switches that are sitting out there? And maybe there's some, other devices that are connected to the network. We need to be able to address security on those devices as well. So, first and foremost, account management is number one. You'd be surprised at how often when I go on site to visit an industrial customer, how many times I see that that's the default password has been assigned or there's no password assigned. And that's really was not our intent. Our intent was that the end user or integrator would go ahead and configure that. So as a best practice, assign a complex password, more than 8 characters, numbers, letters, upper and lowercase, all the things, the same sort of policies that your corporate policies may recommend. Do the same thing in an industrial control system and to things as well. And we've gone so far as on the new E-Series devices to have a pop-up box now that every time you log in, it's going to remind you, hey, set this new password so that you have a higher level of security. Managed devices all have management and secure management protocols on them. So one of the ways you can manage Moxa devices is through a web console using HTTP or HTTPS. So HTTPS is really this secure version of HTTP that uses transport layer security and SSL to provide security to the session. So the recommendation is really to use the secure version of whatever protocol it is that you're using to talk with the management interface. Some customers prefer a console interface, so they'll connect using Telnet or SSH. So we recommend using SSH to secure that console terminal as well. And again, in the E series, we allow you to disable any of those insecure protocols, as well as change the port that the device listens to, so you can really obscure where those ports are and make it harder for people to find. Limiting access to the management interface. So the concept of an accessible IP list or a trusted access list. So we've got this accessible IP, which acts like a access control list. So it really limits the access to the switch itself to a subnet that you define or a management set of workstations, for example. So all other access to the management interface is denied. So many control systems being designed around a flat layer 2 network means that they can't use separate VLANs and more advanced topology methods to accomplish this. So the accessible IP list is a way to limit the scope in this situation, as well as a mitigation against attack as well. So I mentioned briefly in the prior slide using VLANs. You can also separate your control traffic from your management traffic through the use of VLANs. VLANs are commonly used to separate traffic in the networks for a variety of reasons. They allow for a logical grouping of devices irregardless of their physical location. So, as a best practice, if you can, and you have the ability to segment your network by using VLANs and isolating all that management traffic to a management VLAN. So many times switches are designed in a network with more ports that are needed for the application. While this allows for future growth, it can also be a security concern, since there's nothing really preventing someone from connecting a laptop to the switch and using it for whatever their purposes are. So this not only allows unauthorized network access, but could also introduce latency to your control system that that may cause it to fail or act up intermittently. So in our industrial managed switches, we have the ability to lock down ports and disable any of the ones that you're not using. So we recommend that as a best practice to disable any unused ports on switches. To go the next step, you can also lock ports to known MAC addresses. So this is called port security. With the port lock function, the port will not learn any additional addresses, MAC addresses, and it'll only allow traffic from a preset static MAC address that you have in there. So this also prevents someone from disconnecting an authorized device and then plugging in their own computer or whatever into a port to try to get access to your network. And this can be a requirement in certain industries with higher security needs, such as like the nuclear industry, for example. Simple network management protocol. So SNMP is used by tools, industrial network management tools like MXView, to monitor the network and monitor the health of the network and the links between them and really the status of the devices. There are 3 different versions of SNMP. There's version 1, 2, and 3. Version 1 and 2 are sort of legacy, and they use clear text community strings for access. So the downside of this is that if someone had access to your network, they can sniff the traffic and find out what these community strings are and utilize that. So as a best practice, we recommend using SNMP version 3, which includes the security features like encryption, message integrity, and authentication, to make sure that traffic is coming from a valid source and really obscure it from somebody that's doing a packet snooping attack. So along with that is monitoring events. So how do you know when your devices are under attack? You have to have a way of noticing that. And by using a device that has centralized management and logging, such as syslog, this can really ease the burden of monitoring lots of devices in your network. So our MXView product, for example, also comes with a built-in syslog server. So you could use it if you're already using MXView. But you could use any NMS that that contains a syslogger as well. So as configuration changes are made to the devices, those devices can signal to your remote syslog that a change has been made. You can also log failed authentication attempts to prevent tampering of your network and really become aware when someone's trying to hack into your network. So event notification can happen in a lot of different ways, but syslog is one of them. So it really is a best practice. Monitor your network, review compliance to any policies that you might set up for that as a best practice. Which leads us to our next live poll. So which network monitoring solution do you use in your network? Some of the choices here. Let's see. So SolarWinds, MXView, SCADA-based, What's Up Gold, or open source. So here's another one where if you're using something that that's not on the list, we would welcome you to let us know what that is through the comments later.
All right, there is a clear front runner. You guys will all see in a few seconds. We'll keep the poll open for a little bit longer. If you haven't voted, now's your chance to let us know what you're using for network monitoring. All right, we'll give you 5 more seconds. 4, 3, 2, 1. Let's take a look at those results.
SCADA-based is #1. Okay, so that's interesting. SolarWinds looks like it's up there with a strong second, and then open source. So there's lots of open source tools out there that you can utilize to do this. So it'd be interesting to hear which ones people are actually using. And What's Up actually made a showing. Okay, great. Well, thank you for that feedback. So MXView is out there. I see it's actually tied for 3rd there, so it's good to see that MXView is being utilized as well. So we talked about the wireless side of things, or we talked about, I'm sorry, the 4G and the cellular side of things. We also talked about the wired side of things. But what about WLAN? We're seeing much more WLAN or Wi-Fi being implemented in industrial control systems now. And if you look at the diagram on the left, you see that that CNC machine, in the past they had serial ports on them. And so it really drove the need for serial to Ethernet conversion. Well, you know, these systems, they march forward in time and do technology refreshes, and those are now coming with Ethernet ports on them. And a lot of times it's easier to go Ethernet to Wi-Fi to get connectivity from them. So there's a need now for securing these systems over wireless and Wi-Fi. Same thing with the DNP and Modbus gateways that we just released this year as well. So precautions have to be taken to ensure that these devices are only the authorized devices can access that Wi-Fi network. The concept of Wi-Fi security is an entirely different discussion altogether. There's lots of best practices that can be discussed to secure those systems. But many of the practices that we talked about already today can be used on wireless devices, and particularly the Moxa wireless devices. So things about, you know, access control lists and things like that, and using WPA2 security are just a couple of the ways that you can secure those. So in summary, we're reaching the end here. I wanted to leave you with 5 key practices that can be used to drive cybersecurity activity in your control system environment. And these are all in line with ICS CERT requirements and not requirements, but recommendations. So, you know, we talked about security policies, developing a security plan for the network in the design phase, and reviewing that plan for compliance over the operation of your industrial network. Aligning with security standards for your particular industry. You know, some of you chose NERC CIP on the poll question. Other ones were 62443, but there were a whole lot that were undecided. So that's you know, some homework is to find out what's applicable for the thing is that you're designing for your industry. And involve security consultants to determine your security readiness, and your security ready level is very important as well. And if this is all brand new to you, those consultants can help you and walk you through the entire process of securing your design. We discussed blocking access to resources and services through the use of perimeter devices such as VPNs, firewalls, access control lists, and things like that. And also the need for detecting malicious activity. How do you know when your network's under attack? You need a way of knowing that. So monitoring your configuration changes, monitoring the event logs through centralized event logging, and then looking at network performance as well through industrial network management system. Mitigating possible attacks. So this is the implementation of filters or deep packet inspection, as well as securing network services and ports that you need to have open. Many times vulnerabilities exist in these systems because there just is no easy way or no good way of closing the exploit. So in those circumstances, you have to find technical workarounds to make sure that those systems are secured. And then finally, fixing core problems. So when there's a security advisory, getting the latest patch, and then having a plan which goes along with your security policies, planning when you're going to look at these patches and when you're going to implement them and how you're going to reach out to your field deployed devices and patch vulnerabilities should be part of your plan. So thank you for your time today and listening, and at this point we will take questions.
All right. And so before we begin taking questions, just letting you know that it is not too late to send your question. We will be issuing a follow-up to this webinar with a link to the recording and the slides, and we will try to address any questions that we were not able to address live today. So we've already gotten a lot of questions during the course of the presentation, so I'll go ahead and get started, Mike. First question. What are some ways that your company is making cybersecurity easier to implement for integrators? What is Moxa going to do to help us secure our networks?
Okay, well, that's a great question. We covered some of this in the slides earlier, but one of the things that we've been focusing on is integrating 62443 into our design criteria for new products. So, for example, when we design a new product, it's going to have security features built into it. So if you're an integrator, you're going to be able to take that product and build a secure network around it. So you will have the tools in it to provide a secure configuration. The operators then will have the features that are required to lock down their systems. So it can be very simple. So some of the changes could be just to the user interface. It can be as simple as a login screen that tells you to change the default password, for example. Or more complicated, such as being able to notify your NMS when your network's under attack. So if you think about the EDR series, one of the things we did to the EDR series was build in the ability to send an event on a firewall rule being hit. So that way your management system is going to be able to see when you're under attack, and you can take appropriate measures to mitigate it before you have a big problem.
All right, thanks very much for that, Mike, and great question. We've got a lot of great questions here, so I'll just get to the next one. I am tasked with adding security inside of our control system. Is there a way to do this without having to change the IP addressing schemes already in place at existing facilities?
Yes, there is. So, that's one of the realities of the control system networks compared to enterprise networks, is that the ICS networks are oftentimes designed around just a flat layer 2 network where there is just a single subnet scheme in place. So when you have to take an existing design and come back in and add, somebody tells you, well, you're going to have to implement this zone and conduit design. It could be problematic to introduce a new subnet in that design. So how do you create the zone and conduit model? How do you how do you do that? So the simple solution is to use one of those devices that I mentioned earlier, which is the firewall that contains the transparent or bridge firewall. So what that does is it creates a single subnet on both sides. So it's essentially a bump in the wire, so to speak. So all the traffic between zones would flow through it, but the subnets are the same on each side of the device. So this would allow you to preserve the existing IP addressing scheme at existing facilities and probably have the least amount of impact while giving you some level of security in those older systems.
All right, thanks very much, Mike.
Mm-hmm.
That sounds related to this question. Is there an impact on my network performance if I add so many firewalls to secure the network?
That's a great question. So part of the network design, you really must look at in size all the devices that you're going to put inside of the network based on your throughput needs, the amount of traffic that you expect to be flowing across that firewall, and not all devices are created equally. So typically these devices are rated in their ability to process frames per second across it. So if we look at, for example, the high end of the EDR series can support like something around 40,000 frames per second, whereas at the low end it's 10,000 frames per second. So you really, as part of your design process when you're looking at designing your zone and conduit model and analyzing which protocols you're going to be using, you're going to have to look at what the expected traffic is in order to make that decision to size that device there so that you don't end up with a bottleneck in your system. So that's a very good question.
All right, thanks very much, Mike. It looks like we're getting some comments and questions. Here's one of the comments. I don't know if response is needed. Are you familiar with the website INCCam or INSECCam that shows insecure IP cameras?
Personally, no. I try not to spend a lot of time out on those sites. When I first did research for this, I tried one of these sites like SHODAN, and immediately my firewall started to light up. So I got some return traffic from using that, and I kind of learned my lesson. I'm like, okay, this is not a one-way street here. There's someone looking to see who's on the other end. So I try to stay clear of that. But it'd be interesting to know what's there. I know there's lots of interesting things out there.
All right, thanks, Mike. Not something I even considered, but great comment and great answer to that comment. Thanks. Moving on to the next question. We have a few more minutes, so keep those questions coming. And remember that if we don't get to it live during this session, we will try to address it in the follow-up materials. So how secure are VPNs? Can they be relied upon to limit cross-movement once a hacker is inside the external firewall of the network?
That's a good question. So VPN, so once you establish a VPN, what's to prevent somebody from going and having free reign of the network, essentially? And that's where one of our recommendations was to utilize your firewall to prevent what traffic can go back up there. There's also some things you can do with just the design of the network. You can set up parts of that VPN to connect to isolated parts of the network that can't get everywhere, or only to one of those levels or a zone, a secure zone that I mentioned earlier when we talked about the zone and conduit models. So not all connections are at the edge and allow all the traffic through. So there's things you can do with the firewall and also just the strategic placement of where that VPN is to limit what it has access to.
Thanks very much, Mike. Wow, lots of questions. I'm bouncing around here trying to choose a good one and that I actually understand how to articulate. Here's a simple one. Is there a security standard for schools, colleges, and educational institutions?
Very good question. If there is, I'm not aware of it. I guess that's something we'd have to take back to the team and ask to see if anyone internally knows, and we could get back to you on that.
All right, thanks, Mike. Here's another question. I've heard that the OPC UA protocol greatly enhances industrial network security by virtue of the encryption it enables. Do you have any thoughts on how the industry is or may be moving to that standard in the future?
OPC UA is definitely an improvement on the old OPC model that used DCOM and insecure protocols. So it's definitely headed in the right direction, and basically it allows the clients to securely connect to the server. And overall, I think the industry adoption is slow for the amount of value that it brings. So, you know, is it headed that way? Yes, I would say. There's definitely, OPC UA is a great protocol that can be utilized to provide that sort of secure connectivity. I don't see it being widely adopted just today. It's headed that direction, however. There's other protocols out there like MQTT that are becoming very popular for the control system communications now. So MQTT is sort of this publisher-subscriber model that's very lightweight, and it's very lightweight, and especially for use over cellular networks where, you know, you get charged for every byte that goes over. That, you know, this MQTT protocol can be secured through transport layer security as well. So that's starting to see quite a bit of interest now in the industry.
All right, thanks very much, Mike. Great question. Can you compare, from a security standpoint, IPsec and OPVPN? Any personal experience, recommendations, suggestions?
So IPsec. So IPsec is an industry standard VPN. So just about all of the vendors will interoperate if they, you know, comply to the IPsec rules and guidelines. So it's not a closed one vendor type of situation. And actually, so for Moxa, we do our interoperability testing with third party vendors and enterprise class vendors that are leaders in the industry, and we can ensure that, you know, our devices can connect via IPsec. It's also the tools for secure remote access. So if you're that remote engineer, you can just use Windows to connect to an IPsec VPN because the features are built into Windows to do IPsec. So OpenVPN is another standard. It's not an industry standard, but as I understand it, you can download the source code for it and compile it up for just about any platform and run it. It's very cross-platform, which means you can run an application on just about any platform. It can run on a Mac, it can run on, you know, PC, Android, just about any platform you can imagine out there. You can run OpenVPN on, and it makes it very attractive for those that are doing control system security and want to monitor via tablet. So I see this from time to time where, you know, somebody has plant level oversight, and while they're on site, they want to be able to use a tablet to monitor the network and the status of things, and this allows them to securely connect with that. It's a user land, so OpenVPN runs in user land, which means it might not be as fast as IPsec. So, but it also has the ability, if it crashes, it doesn't crash it doesn't give you the blue screen of death. The application just crashes. So. It's a little bit more tolerant. So it really depends on what your needs are. If you're looking for interoperability and inter-vendor connectivity, then, you know, IPsec is the way to go.
Thank you very much for that answer, Mike. I definitely tell you have experience with both of these, and it was a fantastic question as well. So thank you to the person who asked that question. We've hit our time, so that's all the time we're going to have to answer questions. So with that, I want to thank Mike for the information that he shared today. Thanks, Mike. And to everyone here for sticking around, for attending, and for the fantastic questions that you sent us. So with that, I hope you all enjoyed our presentation today. Thanks again, everyone, for tuning in, and please have a great rest of the week.